and the nitrogen dioxide appeared. You probably can't tell the color difference. But there's more NO2 now than there is oxygen. There, now I feel better. But they want the total pressure. And when you're doing with the total pressure, we don't care if it's oxygen or nitrogen, we can just add the two together. If we add the two together, I get 0.264. Now if you want, you can take this and plug it into PV equals nRT to find the total pressure. Because you got the total moles, you got R, you got T, you got P, you got V. The container's 5 liters. Now, when we did this in the beginning, these were the number of moles we had, right? Part 1. And we calculated the total pressure to be, each one was what, 4.28? Right? If I add up the moles, that would be 3.52. So what happened to our total number of moles? It decreased, right? Now they gave us some nice numbers. How much did our total number of moles decrease by? Decreased by, should be decreased by 3/2. No, it decreased by 3/4. It's gotta get smaller. The mole's gotta get smaller.
Oh yeah.
So if you take this number,
No, yeah.
if you take this number and you multiply it by 3/4, if you multiply it by 3/4, that's the number you get. So the moles decreased by 3/4. Sorry to my viewing friends in Poland, I screwed up. It's not 3/2, it's 3/4. So, yak shamash. So 3/4.
Is that kind of a mistake then?
That counts as a mistake.
Alright, fantastic.
Actually, I should say shaprash. So 3/4 of my moles gives me that. So if my moles decreases by 3/4, my pressure is going to decrease by 3/4. So it'd be quicker to say, okay, here's my pressure, here's my pressure. The total pressure originally was 8.56. That's the original total pressure. If my moles decrease by 3/4, my pressure is going to decrease by 3/4.
So but you could just plug it back in.
But you could just take the total moles and just plug it in PV equals nRT. I'm just saying,
Yeah.
I'm just showing you a quicker way to do it, especially if you're given a problem like this on the multiple choice where there's no calculator involved.
Yeah.
You could say to yourself, oh, I'm decreasing the moles by 1/2, the pressure's going to decrease by 1/2.
Wait,
So-
sorry.
No, it's okay.
Wait, but I thought it was a different equation now, or a different situation. So why can we use the part from part A
It's like a different container.
with different stuff? Like it's not N2 and O2, it's.
No, well, it says a different rigid container,
But it's different. It's also
but
it's
the
not,
conditions are the same.
But
So
it's not N2 and O2, which is what it was originally. Now it's
Oh, well, yeah, but the only thing that changes is the
and the actual.
Well, but then the ratio's different too.
yeah, right now.
So, okay, I see what you're saying.
Yeah.
In the original problem, it was N2,
Yeah,
but the moles were the same,
right.
right? So, that's one of, again, the beauties of the ideal gas equation.
All gases are the same.
All gases are treated the same, so as long as it's 0.76 moles, I don't care what the gas is, it's gonna have that pressure. So whatever the gas is, if you've got 0.176 moles of it, the pressure's gonna be 4.28. So I was using the knowledge of that to say, oh, okay, well, in the second part, in part E, I've got this many moles of NO. So if I have that many moles of NO, well then that's gonna be my pressure, and the ratio will be the same, it'll just be a different gas. Instead of being 50-50 nitrogen and oxygen, it's gonna be 50-50 nitrogen monoxide and oxygen.
But does it matter that the mole ratio changed?
The mole ratio,
Of like the NO and O2?
Cause NO is 2.
Cause it's like 2 moles of NO for every mole of oxygen?
yes, we took, yeah, that's why the pressure decreased.
Yeah, but like, so that doesn't matter that the N to an O2 ratio was not the same? Does that make sense?
That still lets us use the
This,
original.
so
0.352
starting,
number.
the ratios were the same of NO
Yeah.
and O2.
But,
But
okay.
NO got used up at a faster rate, so at the end, the ratio is different.
So,
Okay.
but the 2 in front of the NO doesn't,
It's,
It's
you
still
can still
so
use
high,
the
yeah, I was
point three five two
thinking
numbers,
still
right?
But it just
Even-
doesn't
even-
stop,
Oh.
the same number of moles.
They
Yeah,
told
I
us
thought-
we had
I thought
this
the
many
same thing you
moles,
were.
so it doesn't matter what that number is up there.
Yeah.
That number is just used to find out who's the limiting reactant, okay? These are all very good questions, all very good questions. So, I think what we'll do then is, we'll end here, and then for the next review session, I'll pick up with chapter 6 and chapter 7.
what's the next review?
Next review section is next week, Thursday.
Do you have a game?
Yeah, we have,
Ooh, next week Thursday.
the next year.